So here you cannot directly employ the formula because that formula which we have seen is for simultaneous movement. Both persons must be moving at the same time. But here, 1 hour after Harry started walking from A to B a distance of 24 miles, then Tom started walking. So first, let us find out what happens after 1 hour. In 1 hour, Harry is walking alone. So subtract how much distance he has traveled. So A and B are 24 miles apart. First, for 1 hour, Tom is staying here itself. Harry is walking at a speed of 3 miles per hour. So in 1 hour, 3 miles per hour means in 1 hour he will travel 3 miles. So out of 24 miles, if he has already traveled 3 miles, now the distance between Harry and Tom would be 21 miles. Now the distance is 21 miles. And Harry is walking towards Tom at a speed of 3 miles per hour. Tom is walking towards Harry at a speed of 4 miles per hour. Time taken for persons to meet when they are moving in opposite direction. It is distance between them, distance 21 miles by sum of their speeds. Sum is 3 plus 4, 7. 21 by 7, 3 hours. And also, he is not asking us after how much time they will meet. He is asking us by the time they meet how much distance is traveled by Tom. Distance is speed into time. He is a speed 4 miles per hour and is walking for 3 hours. We get it as 12 miles. So first, evaluate the situation happening in first hour. There only Harry is moving. So in this 1 hour, he will travel 3 miles alone. So subtract that. So right now, distance between Harry and Tom is 21 miles. And we have their speeds. They are moving in opposite direction. Time taken for persons to meet is distance between them by sum of their speeds. So 21 by 7, we get it as 3 hours. Then distance traveled by Tom, it is 4 into 3, which we get it as 12 miles. So once try these next two questions using this idea. Third one is same like the second one. So just to give them a try. I'll discuss them in some 3-4 minutes. See, page number is slightly different in my book. So you can go for class exercise. Class exercise on time, speed, distance, and work time. And also, someone, if you have opened this page, please let him know the page number. 178. So just try them once. We will discuss them in 3-4 minutes. Let's discuss these questions. So in third one, two buses P and Q started simultaneously from opposite ends of a 140-mile route and traveled towards each other on parallel roads. Bus B traveling at a constant rate completed the 140-mile trip in 9 hours, and bus Q traveling at a constant rate completed the 140-mile trip in 5 hours. How many miles had bus P traveled when it met bus Q? So here there are two buses, P and Q. They are moving towards each other on opposite roads. So bus P traveling at a constant rate completes the 140-mile trip in 9 hours. So distance is speed into time. If you need speed, speed is distance by time. So speed of P, distance 140 miles traveled by time it is taking 9 hours, 140 by 9 miles per hour. Similarly for bus Q, distance 140 by speed 5, sorry, by time 5. So these are the speeds of those buses. By the time they meet, he is asking bus P has traveled how much distance. So first let us find out how much time it takes for them to meet. Whenever these bodies are moving in opposite direction, time taken them for meeting is distance between them by sum of their speeds. So distance 140 by sum of their speeds, 140 by 9 plus 140 by 5. So calculate what is this, you get it as 45 by 14 hours. It is 45 by 14. Now we have to find out how much distance is traveled by bus P. Distance is speed into time. So speed 140 by 9 miles per hour into time 45 by 14. We get it as 50 hours. Sorry, 50 miles. So find out what is this time, how much time after they meet, which is given by distance between them by sum of their speeds. Direct substitution of values in the formula. Then you get what is this time. Then find out distance. Distance is speed into time. Next one, a car has to travel from New York to Chicago at an average speed of 40 miles per hour and returns immediately along the same route at an average speed of 60 miles per hour. What is the average speed in miles per hour for the round trip? So in this kind of questions, do not simply take average of 40 and 60 and say 50. That's conceptually wrong. So New York to Chicago, it is going at an average speed of 40 miles per hour and returns immediately back from Chicago to New York at an average speed of 60 miles per hour. So for to and fro journey, if you have to find out this average speed or for any particular journey, if you need average speed is calculated by total distance divided by total time taken to travel that distance. Total distance by total time taken to travel that distance. So for any particular journey, if you need average speed, find out how much distance you are traveling in this journey and divide it with the total time taken to travel that distance. So New York to Chicago, let's say they are separated by some d miles. So first you are traveling from New York to Chicago, distance traveled is d miles, and again back from Chicago to New York, distance traveled is d miles. So for forward journey d miles, backward journey d miles. Then total time. Time is calculated by distance by speed. For New York to Chicago, for forward journey, Distance we are traveling is D, speed is 40. Similarly, for backward journey, Chicago to New York, distance is D by speed 60. So forward journey D by 40 plus backward journey D by 60. So we get it as twice 40 into 60 by 40 plus 60. We get it as 48 miles per hour. So if you want, you can also remember this. For a to and fro journey, average speed is calculated by twice the product of their speeds by sum of their speeds. Twice the product 2 into 40 into 60 by sum 40 plus 60. But no need to remember all this. Knowing this is enough. Average speed. Average speed is given by total distance traveled by total time taken to travel that distance. So these are some model problems present on this distance and time related concepts. Speed, distance and time. So if there's any doubt here, let me. So in addition to this, we have work related problems like how to deal with work related problems and as well as unitary relations. Means if one pen costs 10 rupees, 10 pens will cost how much? Or if one person take 10 days to complete a work, 10 persons will take how many days? Those kind of unitary relations. So those ideas we will look through solving problems. So let's see how to deal with work related problems. For example, let's say there is a person A. A working alone can finish a task in 6 hours and B working alone can finish the same task in 8 hours. A working alone can finish a task in 6 hours and B can finish the same task in 8 hours. And let's say we are interested in knowing how much time will it take for work to get completed when both are working together. When both are working together. So A takes 6 hours, B takes 8 hours. Let's say we need to know A and B working together, how much time it will take. So how to proceed with this kind of questions is, you have to start by finding out what is work done in 1 hour. If A takes 6 hours to complete a work, in 1 hour he will be doing 1 by 6 amount of the work. Work done in 1 hour is a reciprocal of the time taken. Work done in 1 hour is reciprocal of the time taken. So if A takes 6 hours, in 1 hour he will be doing 1 by 6 amount of the work. If B takes 8 hours, in 1 hour he will be doing 1 by 8 amount of the work. So A will do 1 by 6 amount of the work, B will do 1 by 8 amount of the work. When both are working together, work done in 1 hour is 1 by 6 plus 1 by 8. So take LCM. You get it as 14 by 48 or 7 by 24. And this is the amount of work done in 1 hour. In 1 hour, if work done is 1 by 6, time taken is reciprocal of that, we say 6 hours. Or in 1 hour, if 1 by 8 amount of the work is done, then time taken is reciprocal of this 8 hours. Like that, in 1 hour, if 7 by 24th amount of the work is done, then time taken is 24 by 7 hours. So this is the process. Finding work done in 1 hour. If A takes 6 hours, we say in 1 hour he will be doing 1 by 6 amount of the work. If B takes 8 hours, in 1 hour he will be doing 1 by 8 amount of the work. And when both are working together, we say work done in 1 hour is 1 by 6 plus 1 by 8. And the time taken is reciprocal of this. So you should know the approach. But in direct questions, you can also employ the formula. If you simply say A takes 6 hours, B takes 8 hours, both working together will take how much time? Like in the direct questions, the formula which we employ is If A takes A hours to complete a work and B takes B hours to complete a work, then time taken for work to get completed is AB by A plus B hours. If A takes A hours and B takes B hours, then time taken for work to get completed is AB by A plus B hours. So in direct questions, you can employ this formula. But in other, if number of persons working are changing in each hour, if new persons are coming and getting added, or already working persons are leaving like that, in those questions, you have to proceed by finding out what is work done in 1 hour. So we are getting this. If A takes A hours, in 1 hour he will be doing 1 by A amount of the work. If B takes B hours, in 1 hour he will be doing 1 by B amount of the work. When both are working together, time taken is 1 by A reciprocal of this 1 by A plus 1 by B. If three persons are working together, then time taken is ABC by AB plus BC plus C hours. Let's say A, B, C, all three are working together. Then it is reciprocal of 1 by A plus 1 by B plus 1 by C, which we get it as ABC by AB plus BC plus C hours. So in direct questions, employ formula or else proceed by finding out what is work done in each hour. And sometimes you will say inlet pipes, outlet pipes like that. In those cases also you can employ this formula. Let's say there is an inlet pipe A which can fill a tank in 6 hours. Another inlet pipe B can fill the tank in 8 hours. If both taps are open simultaneously, how much time it takes for tank to get filled in capacity? So one inlet pipe can fill a tank in 6 hours means it will do its work in 6 hours. A value is 6. Another pipe can fill the tank in 8 hours, so B value is 8. Substitute here. And when he says inlet pipes and outlet pipes, in that case also you can use this formula. But there what you have to do is, if you take inlet pipe value as positive, outlet pipe value must be negative. You have to give the opposite signs there. Because inlet pipe is one which lets water in. Outlet pipe is one which drains water out. They are doing the opposite work, so you have to substitute it, give opposite signs. If A value is 6, B value will be minus 6. So in addition to this, we have, like I said, we have those ideas on unitary methods. Those we will look through solving last two questions here. So in page 178, try the remaining questions from 5 to 8. We will discuss them in few minutes. Concentrate here now. Let's discuss these questions. So 5 to 8. An empty water tank can be filled to capacity through an inlet pipe A in 4 hours, and it can be completely drained by an outlet pipe B in 12 hours. If both the pipes A and B are open at the same time, in how many hours will the empty tank be filled to capacity? So if A can do a work in A hours and B can do a work in B hours, time taken for work to get completed when both are working together is given by AB by A plus B hours. But if you look here, one is inlet pipe and the other is outlet pipe. They will be doing the opposite work. So substitute inlet pipe value as a positive number, then outlet pipe value must be negative. So A value is 4, B value, it's an outlet pipe, so substitute it as a negative, minus 12. By 4 minus 12, we get it as minus 48 by minus 8, which is 6 hours. So if A can do a work in A hours and B can do a work in B hours, time taken for work to get completed is AB by A plus B hours. So one is inlet pipe, A value is 4, other is outlet pipe, so B value is minus 12. Then substitute in the formula and calculate. Next one. Tom, Amanda, and Harry working alone can finish a task in 4, 6, and 12 hours respectively. Tom, Amanda, and Harry start working together and work for 1 hour. Then Tom left, and then Amanda and Harry worked together for 1 hour, then Amanda left. And the rest of the work is done by Harry alone. If the task was started at 10 a.m., then at what time does the task get completed? So Tom, Amanda, and Harry working together can finish a task in 4, 6, and 12 hours. So in this kind of questions, you have to proceed by finding out what is work done in each hour. Because if you employ formula here, the number of persons working in each hour is differing. In the first hour, all 3 are working. In the second hour, only 2 persons are working. And after that, only 1 person is working. So as the number of persons working in each hour is different, in this kind of questions, you have to calculate. Like we have to proceed by calculating what is work done in each hour. In first hour, how much is done. In second hour, how much is done. Then remaining, how much is there. To complete that, Harry has to work how many hours alone. So Tom takes 4 hours to complete a work. Amanda takes 6 hours and Harry takes 12 hours. Tom takes 4 hours, Amanda takes 6 hours and Harry takes 12 hours. So work done in 1 hour. Work done in 1 hour is reciprocal of the time taken. So if Tom takes 4 hours, in 1 hour he will be doing 1 by 4th amount of the work. Amanda will be doing 1 by 6th amount of the work. And Harry will be doing 1 by 12th amount of the work. In 1 hour, Tom will be doing 1 by 4th amount of the work. Amanda will be doing 1 by 6th amount of the work. And Harry will be doing 1 by 12th amount of the work. Next. Then calculate, like here, using these values also we can calculate. Those aren't any difficult calculations, easy calculations only. Or else instead of dealing with these fractions, take some convenient value for work. Let's say total amount of work which you need to do is 12. Because 1 by 4, 1 by 6, 1 by 12, like that fractions are there. Take the total amount of work which is divisible by 4, 6, and 12, which is 12. So take as 12 amount of work. In 1 hour, Tom will be doing 1 by 4th amount of the work. 1 by 4 of 12, it is 3. In 1 hour, Amanda will be doing 1 by 6th amount of the work. 1 by 6 of 12, which is 2. In 1 hour, Harry will be doing 1 by 12th amount of the work, 1 by 12 of 12, which is 1. Now, what is happening in the first hour? In the first hour, all three persons are working. So, work done by Tom 3, by Amanda 2, by Harry 1. In the next hour, in the second hour, only Amanda and Harry are working. Tom left. Work done by Amanda 2, by Harry 1. Now, by this time, some amount of work is done. To complete the remaining amount of the work, Harry is working alone. We don't know how much time he works. First, you need to find that. So, let us say he is working for 10 hours. If he works for 1 hour, work done by him is 1. If he is working for n hours, n into 1, which is 12. So 9 plus this n is 12. You get n as 3. That means Harry is working alone for 3 hours. But he is not asking us how much time does Harry work alone. He is asking us at what time does task get completed. So task is starting at 10 a.m. For the first hour, all three are working. Second hour, only two are working. After that, Harry works for 3 hours more. So total it is 1 plus 1 plus 3. 5 hours after 10. 5 hours after 10 means we say this 3 p.m. So first we are taking some convenient value. Let's say total amount of work which we need to do is 12. Then work done by Tom. In 1 hour, he does 1/4 amount of the work, 1 by 4 of 12, which is 3. Amanda does 1/6 amount of the work, so 1 by 6 of 12, 2. And Harry does 1 by 12th amount of the work, 1 by 12 of 12, which is 1. Then in first hour, all three are working, 3 plus 2 plus 1. In the second hour, only two are working, 2 plus 1. And after that, Harry will work for 3 hours alone. So total task gets completed 5 hours after 10, which we say 3 p.m. So these are some model examples on this work-related problems. Next questions, those are on those unitary relations. Mission A produces toys at a uniform rate of 90 toys in 15 minutes. And mission B produces toys at a uniform rate of 60 toys in 30 minutes. If the two missions are so two missions run simultaneously, how many minutes would it be required to produce a total of 400 toys? So he's asking time for 400 toys. So first let us find out if both missions are working together, in 1 minute how many toys we will produce. Work rates of these missions are given. A in 15 minutes will produce 90 toys, whereas B in 30 minutes will produce 60 toys. So A in 15 minutes is producing 90 toys. That means in 1 minute, using those unitary relations, for 15 minutes, if it is 90 toys, 1 minute means you will divide here 90 by 15, which is 6 toys. Similarly, B in 30 minutes will produce 60 toys. If it is 1 minute, B will produce 60 by 32 toys. So A in 15 minutes produces 90 toys. So in 1 minute we said 90 by 15, 6 toys. Whereas B in 30 minutes will produce 60 toys. 1 minute means 60 by 32 toys. When both missions are working together, in 1 minute, A will produce 6 plus B will produce 2. Total 8 toys are produced. Then to produce eight toys, if it takes 1 minute, then one toy will take less time. So divide 1/8 of a minute. If it is 400 toys, then here we multiply 400 into 1/8, which we get it as 50 minutes. So we are finding out in 1 minute how many toys are produced. In 1 minute, A is producing 6 toys, B is producing 2 toys. So total in 1 minute, 8 toys are produced. Then using these unitary relations, for 8 toys, if it is 1 minute, 400 toys, how much time? 400 into 1/8, we get it as 50. So let's say a small idea regarding this unitary relation. For example, if one pen costs 10 rupees, if one pen costs 10 rupees, 10 pens means you will say multiply here. 10 into 10, you will say 100. If one pen costs 10 rupees, 10 pens would be costing 10 into 10, which is 100. Similarly, if one person takes 10 days to complete a work, for 10 persons, if you need for 10 persons, here we divide 10 by 10, we say 1 day. So whenever you are using these unitary relations, like from one you have to find out for other numbers, or from other numbers you have to arrive at one, like one pen will cost how much, or one person will take how many days, like that. Then if it is more, if a value will be more, multiply. If one pen costs 10 rupees, 10 pens will cost more. So multiply 10 into 10, we say 100 rupees. Whereas if one person takes 10 days, 10 persons will take less amount of time. Less, so divide. So if it is more, multiply. If it is less, divide. Because whenever you are moving from one to other numbers, like 1% to 10 persons, or 1 pen to 10 pens, like that, this is actually based on that directly proportional and inversely proportional, which we will be discussing in equations and ratios. But no need to know those. Instead of complicating, one simple idea which you can remember here is, whenever you are using these unitary relations, if a value will be more, multiply. If one pen costs 10 rupees, 10 pens will cost more. So you multiply 10 into 10. Whereas if one person take 10 days, 10 persons will take less amount of time. Less means divide 10 by 10. So in the next one, let us employ this idea. 4 identical taps can fill a 100-liter tank in 6 hours. Then how many hours will it be required to fill a 150-liter tank by 8 such taps? So here number of taps are changing, and the volume which needs to be filled is also changing. 4 taps will fill 100 liters in 6 hours. He is asking for 8 such taps and 150 liters. So first let us change one constraint. First let us change the number of taps to 8. 8 taps, 100 liters, let us find out that time. 4 taps will take 6 hours. 4 taps to fill 100 liters will take 6 hours. If it is only one tap will take more amount of time, more. More means multiply, you say 4 into 6. If it is one tap, it takes 24 hours.